units in imaginary quadratic fields. These are the quadratic fields Q root m. M is square free and m is negative. M is a square free integer, m is negative. Which integers in these fields are units? And the theorem is let k equal to q root m. This is called as an imaginary quadratic field. The units in k are for m equal to -1 plus -1 plus minus I. M equal to -3 plus -1 plus minus omega plus minus omega square, where omega is -1 plus root of -3 by 2. In other words, these four numbers can be written as plus -1 plus minus 1 plus or minus root of -3 divided by 2. These four numbers you can write in this form. And for other values of m, that is m equal to -2, then -5, -6 and so on, the units are just plus minus 1. For m not equal to -1, -3, just plus or minus 1. They are the only units. So in the first case, m equal to -1, there are 4 units. For m equal to -3, there are 6 units. They are all roots of unity. These are 6th roots of unity. These are 4th roots of unity. And here we get just plus minus 1. So for example, q root -2, what are the units? Only 2 units, plus minus 1. Q root 2, if you consider, then infinitely many units. But q root -2, there are only 2 units. To prove this, let epsilon be a unit in q root m. Now what is norm of epsilon? So take epsilon equal to a plus b root m, or by 2. There can be a denominator like this, where this is in the and a, b both are odd. That is this situation. You can get epsilon in this form, because epsilon is an algebraic integer, and so it has these possibilities. These are the only possibilities. What is the norm of epsilon? Norm of epsilon equal to plus or minus 1 since epsilon is a unit. Now if you use the formula for epsilon, that way of writing A plus B times M, what is the norm? So norm of epsilon is A square minus B square M or A square minus B square M divided by 4 for M congruent to 1 mod 4 AB odd. These are the possibilities for norm of, but M is negative, so minus M is positive. You see that this is positive, therefore norm of epsilon is positive, and therefore norm of epsilon is equal to 1 only. It cannot be minus 1. Norm cannot be minus 1 in this case when M is negative. In the first case, A square minus B square M is equal to plus 1. Norm is plus 1. If M is less than or equal to minus 2, then A square minus B square M, so minus 2 is bigger equal 2, so it is bigger equal to B square. Now if B is 0, then A equal to plus minus 1. If B is not equal to 0, A square minus B square M is at least 2. But you want it to be 1. So there is no unit for which B is not equal to 0. So no unit with B not equal to 0 of this type, 0 in the first case. Thus, if M is less than or equal to minus 2 and M not congruent to 1 mod 4, then epsilon equal to plus or minus 1. Okay, this is the only possibility. If M equal to minus 1, which is not 1 mod 4, A square, so M equal to minus 1 gives A square minus MB square equal to A square plus B square equal to 1 gives A equal to plus or minus 1, B equal to 0, or A equal to 0, B equal to plus or minus 1. These are the only integer solutions. Thus, epsilon is either plus minus 1 or plus minus I. And these are they are algebraic integers. In the quadratic field and they are units. Their norm is 1. Okay. So first case is over. What happens if m equal to minus 1? What happens if m less than equal to minus 2? Both the things we have considered.